We have seen that we can figure out the value of an integral using the fundamental theorem of calculus, provided we can find a function whose derivative is the integrand. This leads us to the study of antiderivatives. The antiderivative of a function is just a function whose derivative is that original function. Let's look at a few examples. Let's look at an example where we're given the function little f of x is equal to 3x squared, and we want to find a function capital F of x, so that capital F prime of x is equal to little f of x. So we need to think of a function whose derivative is 3x squared. So we think through various functions and what their derivatives are and see if we can just pick one whose derivative happens to be 3x squared. Well, you could think of the function being x. Well, the derivative of x is 1. That doesn't work. You think of x squared, but the derivative of x squared is 2x. That's not going to work. But if we use the function x cubed, that's going to work really well. The derivative of capital F of x, the derivative of x cubed is 3x squared. We're thinking backwards. We're trying to think of a function whose derivative is 3x squared. That's called the antiderivative. We just guessed at this. We'll see later how to find a rule for this, which will make the job of finding antiderivatives for these kinds of functions easy. But notice right now this isn't the only function that we can use. We could also use x cubed plus 4. That would be an equally valid function that we could pick. The derivative of x cubed plus 4 is 3x squared plus 0. That's the same as what we started with, 3x squared. So this is another antiderivative of this function. Or we could use x cubed plus 5. That would be another antiderivative. Or in general, we could use x cubed plus c, where c is any constant. This is called the general antiderivative, and it can be shown that every antiderivative of this function is of this form, x cubed plus some constant. That is, any function whose derivative is 3x squared has to be x cubed plus some constant. Let's look at another example. This one, we're given the function f of x equals 4. We want to think of a function whose derivative is 4. So think about the various functions you know, and think about their derivative. Go through a list perhaps, and you pretty soon realize that the function that we need is 4x. The derivative of 4x is 4. So that would be one antiderivative. We could add on any constant. Pi is a constant, 4x plus pi. The derivative is also 4. 4x plus pi, the derivative is 4 plus 0. Or we could subtract the square root of 2. Square root of 2 is a constant. In general, we can have 4x plus any constant as being an antiderivative. All antiderivatives are always of the form of one particular antiderivative plus a constant. This is the general idea of what an antiderivative is.